All right, my secondary math 1 class, we are going to be continuing to talk about triangles. Today we will be talking about the Pythagorean theorem a little bit more. In fact, that's what we're going to be focusing mostly on today. But before we do that, let's go ahead and just review finding the missing angle when given two angles, okay? So we know, let's write this triangle or this note just to remind us. We know that all angles in triangles add to 180. Okay, so remember, this is when we're talking about the angles. We're not talking about the sides. Okay, so all three angles inside here will always equal 180 when you add them up. Okay, so knowing that, we can look at numbers 1 and 2, and we can identify the two angles that it gives us. Okay, so for number 1, it gives us 22 and 128. Okay, so we need to find that third missing angle. Okay, so in order to do that, we need to take our total number of degrees, which is 180, and we need to subtract the two angles that it gives us. So 180 minus 22 minus 128. Okay, and if you don't want to do this in your head, you are always welcome to use a calculator. Okay, so we can do 180 minus 22 minus 128, and we know that that third angle, that missing angle, has to be 30 degrees. Okay, so we know that that third angle is 30 degrees. Okay, well, let's look at number 2. So what are the two angles that we know in number 2? So we know 45, and then we always know that this little box symbol equals 90 degrees. Okay, so those are the two angles that we know. So we're trying to find our third angle, which is this question mark. Okay, so again, we're going to take our total number of degrees, which is 180, and subtract the two angles that it gives us, minus 45 and minus 90. Okay, so again, we can use a calculator. 180 minus 45 minus 90 equals 45 degrees. So we know that that missing angle right here is 45 degrees. Okay, so now let's look at 3 and 4. So again, let's look at the directions here. It's not asking us to find the missing angle, it's asking us to solve for x. Okay, so first thing we're going to do is, just like in numbers 1 and 2, we're going to identify the two angles that we know that it gives us. Okay, so in number 3, it gives us 50 and 80. Okay, so we're supposed to find the x in this third angle right here. So in order to do that, we're just going to treat this like it's just a question mark, just like in numbers 1 and 2. Okay, so we're going to take our total number of degrees, which is 180, subtract the two angles that it gives us, 50 minus 80, in order to get that third angle. Okay, so let's go ahead, put that in our calculator. 180 minus 50 minus 80, and we get 50. Okay, so we know that this angle right here has to equal 50. So in order to solve for x, we're going to take what's inside that angle, which in this case it's 10 times x, set it equal to what we found, 50. Okay, so now we can go ahead and solve for x. So in order to solve for x here, there's only one thing we have to do. So looking at this side, there's one thing we have to undo in order to get x by itself, and that is the opposite of times by 10. So what is the opposite of times by 10? You're going to divide by 10. Okay, that gets rid of it on this side, meaning all I have left is my x. 50 divided by 10 is going to give me 5. So we found our x equals 5. Okay, so let's do the same thing for number 4. So let's identify the two angles that it gives us, the two angles we know. So we know 65 and we know 90. Okay, we don't know this third angle with our equation in it, so we're just going to treat that like it's a question mark for now. Okay, so again, we're going to find that third angle by taking our total number of degrees, which is 180, subtract the two angles that it gives us, 65 and 90, in order to find that third missing angle. Okay, so I got 180 minus 65 minus 90, and that's going to give me 25. Okay, so I know that this third angle right here has to equal 25 degrees. So in order to solve for x, we're going to take what's inside of it, 3x plus 1, and set it equal to what we found, 25. Okay, now we can go ahead and solve for x. Okay, so looking at my side with the x, I have two things I have to get rid of, a times by 3 and an add 1. Okay, we need to get rid of the add 1 first because it's farthest away from the x. So what is the opposite of add 1? We're going to subtract 1. Okay, this leaves me with just 3x on this side. 25 minus 1 is 24. And we're almost done. Okay, my very last step to get x by itself is do the opposite of times by 3. Well, what is the opposite of times by 3? You're going to divide by 3. That gets rid of it on that side, so x is all that's left over. 24 divided by 3, I'm going to double check this in my calculator, is 8. So we found that our x equals 8. Okay, so we had to find the missing angle in order to set it equal to that equation and solve for x. Okay, so now we're finding missing angles in 1 through 4. In numbers 5 through 8, we are finding missing sides. Okay, well, in order to find missing sides of right triangles where they have a right angle in them, we have to use the Pythagorean theorem. So let's go ahead and remind ourselves what the Pythagorean theorem is. Okay, so the Pythagorean theorem is always a squared plus b squared equals c squared. Okay, and just to remind ourselves what a, b, and c are, let's draw ourselves a little right triangle. Okay, we know that the two sides that form the right angle are legs, and the side across from our right angle is our hypotenuse. Okay, well, our hypotenuse always has to be C. Okay, that's the most important part. Our legs can be either A or B, so it actually doesn't matter which one you choose. That one can be A, that one can be B. You could have switched those, but as long as your hypotenuse is C, you're good. Okay, so let's now go ahead and identify in number 5 the sides that it gives us. Okay, so I know that across from my right angle is my hypotenuse, so 5 has to be C. Okay, once I know that 5 is C, I can just label A as my 4 and B for my X. Okay, and once I've labeled those sides, I can now plug it in to the Pythagorean theorem. So A squared, my A is 4, so I have 4 squared, plus B squared, my B is X, so X squared, equals C squared, my C is 5, so 5 squared. Okay, well, now we can start solving for X. So first thing we want to do is get rid of these squareds, okay? Well, we know what 4 squared is. What is 4 times 4? It's going to give me 16. Okay, we can't simplify X squared because we don't know what it is, so that just has to stay X squared equals 5 squared, or 5 times 5 is 25. Okay, well, now I'm trying to get X by itself. So I have a 16 and a squared I need to get rid of. First thing I got to get rid of is this positive 16. So what is the opposite of positive 16? We're going to subtract 16 from both sides. So I get X squared is still left over here, equals 25 minus 16 is going to give me 9. Okay. Now my very last step to get X by itself is I have to do the opposite of squared. Remember, the opposite of squaring something is to square root it. Okay, those cancel each other out, so I'm just left with X. And now I can do the square root of 9, or what is the number that multiplies by itself to give me 9? Okay, if you can't think of this off the top of your head, remember our calculators here have a little button, so you want to click second, and then you want to go all the way down here. There's a little square root symbol over the x squared button, so press that. Then you can type in 9, and that's going to give me 3. So my x equals 3, or in other words, my missing side was 3. Okay, now let's look at 6. So first thing we need to do is identify A, B, and C. Okay, so first thing, you usually want to find your C. So across from your right angle is always your C. So I know 10 is my C. I'm going to do X as my A and 8 as my B. Okay, now that I know A, B, and C, I can fill it into my Pythagorean theorem. So A squared first, so X squared, plus B squared, my B is 8, so 8 squared, equals C squared, C is 10, so 10 squared. Okay, now we can start simplifying in order to solve for X. So I want to change 8 squared and 10 squared. So what is 8 squared? Or 8 times 8? We get 64. Okay, I want to change 10 squared, or what is 10 times 10? 100. Okay, and remember we can't simplify x squared because we don't know what x is, so that just has to stay x squared. So now I have x squared plus 64 equals 100. So looking at my side with the x, because we want x to be by itself, do I need to get rid of the squared or the plus 64 first? I need to get rid of the plus 64 first because it's farthest from my x. So I need to do the opposite of plus 64, which is going to be to subtract 64 from both sides of my equal sign. I get x squared is left over equals 100 minus 64 is 36. Okay, and my very last step to get x by itself, the opposite of squaring something is to square root it, cancel each other out. X is all by itself. Square root of 36, if you want to put that in your calculator. So you can do clear, second button, all the way down here to x squared because it has a little square root symbol. 36, enter, and we get 6. So I know that my missing side of this triangle was 6. Beautiful. Okay, so on numbers 5 and 6, we got some pretty answers, meaning we got whole numbers, no decimals, no radicals. They were nice and pretty. Okay, these are actually what's called Pythagorean triples. Okay, 3, 4, 5 is a Pythagorean triple. 6, 8, 10 is a Pythagorean triple. But on numbers 7 and 8, they're not going to be as pretty. Okay, but we're still going to solve them the exact same way. So on number 7, let's go ahead and identify A, B, and C. Okay, so I have my C is 12. First thing I want to identify. I'm going to make X my A and 6 my B. Okay, so now I can fill in my Pythagorean theorem. A squared is X squared. My B is 6. 6 squared equals C squared. 12 squared. Okay, well now I can simplify. We can't simplify x squared because we don't know what it is, so it just has to stay x squared. But we can identify what 6 squared is, or 6 times 6. That's going to give me 36. And 12 times 12 is going to give me 144. Okay, now in order to solve for my x, I need to get rid of this plus 36. So I do the opposite, which is going to be to subtract 36. Okay, so I get x squared is all by itself, and 144 minus 36 is going to give me 108. Okay, now 108, I don't know if we can get a perfect square, because remember we have to square root it when we enter it in. Okay, so in your calculator, let's go ahead, second square root button, 108, and let's see if we get a nice pretty number. Nope, we get this huge long decimal. Okay, so instead of that huge long ugly decimal, we're actually just going to leave it in radical form. So x is equal to the square root of 108. And that's as pretty as it's going to get for number 7. Okay, so let's try it again for number 8. Okay, so let's identify A, B, and C. So C is my 15. A, I'm going to make X again, and B is this root 122. Don't be too scared by this. I'll show you what happens. It's actually kind of nice. Okay, so AX, or A squared plus B squared equals C squared. My A is X squared, plus B squared, root 122 squared, equals C squared. Okay, now remember when I said that it's really nice when this radical and this square line up? Okay, well, just like up here, how they can't be together, again, they can't be together right here either. Okay, so whenever you see a radical and a square, they just cancel each other out, and you're just left with what's inside. So we just have 122, so X squared plus 122 equals, whoops, sorry, I just bumped my phone, 15 squared, or 15 times 15, is 225. See? Those radicals aren't even there anymore. Okay, so now I got to get rid of that plus 122, so I need to subtract 122. Okay, from both sides, so I get X squared is equal to 225 minus 122. I'm putting in my calculator right now. I get 103. Okay, my last step for getting X by itself, I need to square root it, because the opposite of squared is square root. So that gives me my X by itself. Let's check and see if the square root of 103 is nice and pretty. So second square root button, 103, enter. Nope, we get a big ugly decimal. So instead of writing that big ugly decimal, we're just going to write X is equal to the square root of 103. And that is it. Okay, not too pretty. They don't always end up perfect, like on 5 and 6, but they're as pretty as they're going to get sometimes. Okay, those are your notes for today. You have an assignment that goes with it.